All right, so the objective is to determine three things. You want to determine the value of the discriminant. After you determine the value of the discriminant, you're going to determine the number and type of solutions to the equation. Tomorrow, we're going to find the actual solutions to the equation. Today, we are just determining the number and type. Tomorrow, we're going to learn the quadratic formula. The quadratic formula will give you the actual solutions. Today, we are learning the discriminant, which is a part of the quadratic formula. In order to use the quadratic formula, it has to be in standard form. It has to be set equal to 0. So in order to use the quadratic formula, we have to be in standard form, set equal to 0. And then this right here, this is the quadratic formula. That's the next question. Yep, this right here is the quadratic formula. Okay, what is the discriminant? The discriminant is b squared minus 4ac. That is all we are looking at today. This is typed for you. It is the definition of the discriminant, which says that the discriminant is under the radical but does not include the radical. It is under but does not include. It determines the number and types of solutions. And there are 3 cases, and we're going to talk about those 3 cases next. So, the discriminant has 3 cases. Case 1 is the answer you get for the discriminant is positive. If the answer you get is positive, then you have 2 real roots. If the answer you get is negative, then you have 2 imaginary roots. If the answer you get is 0, then we have 1 real root. And that 1 real root is what we call a repeated root. So if the discriminant is positive, the graph crosses the x-axis twice. If the discriminant is 0, it crosses the x-axis never, but the vertex is on the x-axis. And if the discriminant is negative, then it never crosses the x-axis. The graph is entirely above or entirely below. So example number 1, find the discriminant. So step 1, is it set equal to 0? Yes. Step 2, you need to know what A, B, and C are. So A is always with x squared, B is always with x, and C is no variable. So the discriminant is b squared minus 4ac. So I'm going to plug in b minus 4 A is 1, C is 4, and I'm going to get a number answer. When you type in b squared to your calculator, you need to ensure that you have the parentheses around it. So if you type this in on your calculator, you want to put parentheses around the b value, and you want to have parentheses around the 4ac. So if you type this in on your calculator, you need parentheses in 2 spots. You actually don't need these parentheses in here. You can simply type 4 times 1 times 4.
No, enough with the songs, please. They're the worst. They're terrible.
Wait, where is it equal to negative?
Did you have to type up these lyrics? Oh, it's so funny.
Wait, where are you getting the negative 12? Oh, never mind.
Okay.
That was sorry.
Are you sure you're okay?
Because I saw that 4 minus.
I don't know where we're getting the negative.
Okay. So, go backwards. We're just going to clear it all out, right?
Yeah.
So this is the quadratic equation in standard form. The discriminant is that equation I wrote down. The discriminant is b squared minus 4ac. In standard form, it goes ax squared plus bx plus c. So we pull the b from here. So in this case, b is negative 2. So that plugs in for b squared. The minus 4 is part of the equation. The a value is what's on the 1, so that's 1. And then the c value is at the end, so that's 4. So negative 2 times negative 2 is 4. 4 times 1 times 4 is 16. So I get 4 minus 16, which is negative 12. That negative 12 represents the value of the discriminant. A negative discriminant tells me that I have 2 imaginary roots.
So what's the final answer to negative 12?
The,
Or is it the whole 4 minus 16
yes.
equals negative?
So like the negative 12 represents the value of the discriminant. The discriminant tells you the number and type of solutions. I missed your question because I had like 3 things happening at once.
What's your answer? Is it the negative 12 or is it the 4 minus 16?
Negative 12 is the answer.
And then we just put like 2 imaginary roots or 1 real root or 2 roots. We just write that. We don't.
So number 2 is now equal to number 1. That is not standard form. So you have to move the 1 to the other side. A is 3, B is 5, C is negative 1. So the discriminant is b squared minus 4 times a times c or 37. So 37 represents the value of the discriminant. 37 is positive. So that tells me I have 2 real roots. 37 does not represent the roots. It just tells me the number and type. 37 does not represent, it just tells me the number and type. Tomorrow, we're going to use the 37. Job. In this example, you can either move both to the right or the 10 to the left. So you could say negative x squared minus 10x minus 25, or you could say x squared plus 10x plus 25 equals 0. This equation and this equation mean the same thing. They mean the same. So the discriminant is b squared minus 4 times a times c. So if you use the positive, it looks like this. If you use the negative, it looks like this. Either way, you get 100 minus 100. So we get the value of the discriminant is 0. If the value of the discriminant is 0, I have one real root. If you have one real root, then that tells you the vertex is on the x-axis. And that's what we're going to look at for the next one, is what do these look like graphed? Because again, this is the last unit of chapter 5. So that means we're going to start reviewing, which means we're going to start looking at graphing again. So the discriminant describes the number of x-intercepts, because the root solutions and zeros are all sort of the x-intercepts. They just have different names. So the roots or solutions, they're always given to you as x equals a number or a variable or a power, etc. An x-intercept or a 0 is always given to you as a point on the graph where y is equal to 0. So the x-intercepts and zeros are always a point where y is equal to 0. A root or solution is always an x equal. That's the difference between those four terms. Roots or solutions are x equals. X-intercepts and zeros look like a point. So in this example here, the next three examples are all going to have vertexes that go through -3. We're going to find our discriminant. So I'm going to do the discriminants in red and then the graphing in blue. So the discriminant is b squared minus 4ac. So a positive discriminant tells you you have two real roots. That means we're going to cross this line here twice. So it's going to cross the x-axis when we graph it twice. So we're just going to go backwards and sort of review how to graph. The 3 represents the y-intercept. So that means I have a point at 0, 3. And then we need to find h and k to find the vertex. H is negative b divided by 2a. Or at negative 3. And to find k, you plug negative 3 back in. So this graph contains the point negative 3, positive 6, and negative 6, positive 3. So do you see how the graph hits twice? So that's what the discriminant tells me. It tells me those 2 points exist. The quadratic formula is going to tell you where those 2 points are. The quadratic formula is going to tell you where. The discriminant tells you how many. Let's look at one more graphic. So let's find our discriminant. What?
Do we not have any homework tonight?
You have homework.
I was just wondering, I didn't see that it said that. No, I didn't think there was homework. Usually there's a table with any homework.
So we get 36 minus 40, which is negative 4, and negative 4 tells you you have 2 imaginary. That means that this graph is never going to cross this line right here. So we're going to find h and k. The h value for every problem I picked today is the same. It's negative b divided by 2a, or negative 3. I did that on purpose just so we could see all 3 graphs centered around the same axis. Plugging negative 3 in. We have the point negative 3, positive 1. So you can see that this graph opens up and never crosses that line. This is starting to help see how the discriminant, the number and type, and the graphs all relate to each other. I promise I don't make you graph on your homework. Okay, discriminant. You get 36 minus 36, which is 0. So that tells me I have 1 real root at the vertex. So that's why finding our vertex is so helpful. So the vertex is at -3, 0. That's your y-intercept, so you have a point at 0, 9 also. So that just helps you see your graph opens up. And we can see how it only crosses once. Okay, so your homework is the front and the back of the next page in that packet. On your homework tonight, you are just finding me this part right here. You're finding the discriminant, and then you're describing what that discriminant means.